A retail sporting goods store estimates that weekly sales and weekly advertising costs are related by the equation S equals 2200 plus 80x plus 0.25x squared. The current weekly advertising costs are $1,900, and these costs are increasing at a rate of $175 per week. Find the current rate of change of the weekly sales with respect to time. In your sales function highlighted in teal, take the derivative of each term. 2200 is a constant, so its derivative is 0. 80x has a derivative of 80. Since that variable x changes with time, you have the differential dx over dt. Third term, take the derivative. 0.25 times 2 is 0.50 x, and then again dx dt. The advertising costs for that week are $1,900, so that's going to substitute in for x. The costs are increasing at a rate of $175 per week, so that's your dx dt differential value. Substitute your numbers in carefully, and you'll get a current rate of change of weekly sales of $180,250 per week. A price or demand function is the price charged depending upon the number of units sold. Revenue is the number of units sold times the price at which they are sold. So you get R equals X times P. Think of it as the money you make from selling a product is the price you charge per item times the number of items you sell. Also recall that profit equals revenue minus cost. Example, a company is increasing the production of a product at the rate of 25 units per week. The demand and cost functions for the product are given by lowercase p, 60 minus 0.03x, and cost, capital C, 4,000 plus 40x minus 0.04x squared, where x is the number of units produced per week. Find the rate of change of the profit with respect to time in dollars per week when the weekly sales are 600 units. So we have to create a revenue function, x times p. Take your demand function, x distributed, that's going to give us 60x minus 0.03x squared. Now to create a profit function, you take the revenue function you just created and subtract the cost function that was given in the problem. For revenue, you have an unwritten 1 in front of the parentheses. When you distribute it, everything stays the same. However, when you subtract your cost function, you'll need to distribute your negative. Carefully change all the signs and then combine like terms. Negative 0.03x squared plus 0.04x squared gives you 0.01x squared. 60x minus 40x is 20x. And then the only constant you have is negative 4,000. Now that you have your profit function, we need to find the rate of change in it. So take your first derivative. Our first term, we have 0.01x squared. Its derivative is 0.02x. Since x changes with time, you have a differential dx over dt. 20x has a derivative of 20. It has a variable x, so dx dt. Negative 4,000 does not have a variable. It's a constant, so its derivative is 0. We have an x value of 600 and a dx dt value of 25 from the description in the original problem. Carefully substitute those in. You'll have 0.02 times 600 times 25 plus 20 times 25, giving you a rate of change in profit of $800 per week. A company is increasing the production of a product at a rate of 30 units per week. The cost and demand functions are given. X is the number of units produced per week. Find the rate of change of the profit with respect to time when the weekly sales are 500 units. Now this problem is sort of a copy of the one just before, I did make a few modifications to the functions and the number of units of weekly sales, just so that we'd have a second example to look at. Again, if you don't have a revenue function given, you create one from the price function. Revenue is X times price. For this problem, it's going to be 50X minus 0.02X squared. Profit is revenue minus cost. Take the revenue function that you just created, subtract the cost function that's given. For revenue, you have an unwritten 1 in front of the parentheses, and so when you distribute it, no signs change. You still have those same two terms. When you distribute the negative sign throughout the cost function, you have to change the sign of all your terms. And make that 2 look a little better. Okay. So revenue, don't change any signs. Cost, change all the signs. Once you've got your terms expanded and the parentheses removed, combine like terms, negative 0.02x squared plus 0.03x squared, that's 0.01x squared. 50x minus 40x is 10x. Minus 5,000 is the only constant we have. So now we can take our derivative. The change in profit over time is 0.02x dx dt plus 10 dx dt. That derivative is 0. Carefully sub in 530 from the description in the original problem, and we will get a change in profit of $600 per week. The profit for a product is increasing at a rate of $5,600 per week. The demand and cost functions for the product are given. X is the number of units produced per week. Find the rate of change of sales with respect to time when the weekly sales are 16 units. Okay. The rate of change in profit is given this time, so we're going to have to be careful when we do our substitutions later in the problem. Now, as far as the business of things, we're going to maintain the same action that we did on the previous two problems. We don't have a revenue function given, so it's going to be hard to create a profit function. But since we're given a demand function or a price function, we can create revenue. X times P is going to be 6,000x minus 25x squared. You distribute an x throughout your price function. Once you have your revenue function, since cost is given, we can create profit by doing revenue minus cost. So we have our revenue function that we just created minus the cost function that was given. Distribute your 1 and negative 1, clean up your terms, and then combine like terms. We have a negative 25x squared. That's the only squared term. 6,000 minus 2,400, that's 3,600x. Minus 52 is the only constant. Now we're ready to take the derivative. The derivative, we have negative 50x dx dt plus 3,600 dx dt, and then negative 52 as a derivative of 0. Now, both of these terms have a dx dt attached, and ultimately that's what we were asked to find. We were given the change in profit was $5,600. X equals 16. Both of these are found in the description of the problem. For this problem, we're asked to actually find dx dt. So we factor out the dx dt over here. We leave the negative 50x plus 3,600 inside. Substitute 16 in for x, and in the bracket, you get a total value of 2,800. Solving for dx dt, you divide 5,600 by 2,800, and that'll give you a rate of change of 2 units per week. I hope this video has helped out. If you have any questions, let me know. Reach out by phone or email. If you're on campus, stop by.